And the task before us now is to keep NASA heading onward and upward. Artemis, DART, the James Webb Space Telescope.
Voyager One has been on a 45-year journey through the depths of the universe. But recently, something extraordinary has captured the attention of scientists and stargazers alike. In a surprising turn of events, Voyager One has stumbled upon what NASA experts are calling an impossible discovery. Armed with its scientific instruments and insatiable curiosity, Voyager One has unveiled a cosmic mystery that challenges our understanding of the universe. So join us as we explore how NASA warns that Voyager One has made impossible discovery after 45 years in space. Voyager mission's epic journey. For nearly 50 years, the Voyager missions have played a crucial role in space exploration, providing early and enlightening insights into the vast wonders of our solar system. Surprisingly, these missions were not originally designed for long-term endurance. In the 1970s, Michael Minovich discovered the concept of sending out probes. A pivotal moment occurred when he realized that a spacecraft could leverage a planet's velocity to propel itself deeper into the solar system. Initially projected to endure a modest 5 years, the Voyager mission has significantly surpassed expectations. Launched within weeks of each other in the summer of 1977, Voyager One and Voyager Two were initially tasked with exploring Jupiter and Saturn, achieving their mission objectives successfully by conducting comprehensive studies of these gas giants. What makes their achievements even more noteworthy is that they did not conclude their exploration at this point. Voyager 2 accomplished an impressive milestone by conducting the initial close-up examinations of Uranus in 1986 and Neptune in 1989. These flyby journeys, encompassing the 4 planets, led to the missions being dubbed the Voyager Grand Tour. Instead of concluding their mission, the resilient Voyager pair then embarked on a more ambitious endeavor, exploring the uncharted regions of deep space. Fast forward 46 years, and Voyager 1 and Voyager 2 are still actively collecting essential scientific data from the farthest reaches of the cosmos. In a noteworthy development shared by NASA in 2013, Voyager 1 officially entered interstellar space, which refers to the space between stars and the profound depths of the cosmic realm. Why is the delineation of this boundary significant? As explained by experts at NASA, interstellar space is encountered when the continuous emission of particles and magnetic fields from the Sun temporarily subsides. This transition can be likened to departing the bustling vicinity of the solar system and entering a tranquil, star-filled wilderness. Notably, the Voyager mission extended beyond the solar system. In 2018, Voyager 2 marked its entry into interstellar space at a considerable distance of 17.7 billion kilometers from the Sun. Remarkably, as of the present, Voyagers 1 and 2 stand as the sole spacecraft to have ventured into the unexplored realm of interstellar space. Beyond mere celestial observation, these pioneering spacecraft have been actively engaged in scrutinizing the complex interactions between the interstellar medium and our Sun's particle-laden solar wind. You see, the collaborative efforts of Voyager 1 and 2 have consistently provided us with crucial information regarding the heliosphere, an enveloping shield safeguarding our solar system. The heliosphere, influenced by the solar wind, a continuous stream of charged particles from the Sun, is shaped and adjusted by these spacecraft. Voyager 1 and 2 functions as our celestial correspondents, transmitting valuable insights on this astronomical protective barrier. The convergence point of these phenomena is officially recognized as the heliopause, marking the boundary of our solar system. At this juncture, the solar wind bids farewell, and interstellar space expansively unfolds its mysteries, an astronomical rendezvous symbolizing the transition between our familiar solar vicinity and the vast unknown. Voyager's revelations. Beyond the heliopause, NASA's Voyager spacecraft has provided valuable insights into the mysteries of interstellar space. One noteworthy discovery is that cosmic rays, those elusive particles, exhibit 3 times greater intensity beyond the heliopause compared to within the heliosphere. This contrast can be likened to the tranquility of the solar backyard, in contrast to the vibrant cosmic activity just beyond. However, the narrative doesn't conclude here. NASA's adept researchers have not only acknowledged Voyager's revelations, but have also integrated data from subsequent missions, crafting a comprehensive cosmic collage that enhances our understanding of the Sun and its complex interactions with the surrounding interstellar space. In a profound cosmic revelation last year, NASA scientists disclosed a noteworthy finding. Voyager One registered a continuous sound akin to the waves identified in minimal amounts of gas present in the sparsely populated expanses of interstellar space. Nicola Fox, the director of NASA's Heliophysics Division in Washington, D.C., underscored the significance of the Voyager missions. In her own words, "Throughout the past 46 years, the Voyager missions have been pivotal in imparting this knowledge and have revolutionized our comprehension of the Sun and its impact in ways unparalleled by any other spacecraft." Now that's a remarkable cosmic journey. Here's the intriguing detail. Voyagers 1 and 2, those resilient space pioneers, operate using a plutonium-based thermoelectric power system. As plutonium undergoes its processes, the heat production decreases, leading to a decline in power for the Voyager spacecraft. In response to this cosmic challenge, NASA had to make strategic decisions, deactivating non-essential and even some initially deemed crucial systems. The heaters, originally designed to maintain the instrument's optimal temperature in the cold vastness of space, were powered off. However, against expectations, all 5 instruments have continued to operate successfully since 2019, defying the odds. NASA experts are currently perplexed, contemplating the cosmic enigma. How, amidst extreme temperatures that would typically incapacitate other spacecraft, do the Voyagers persist in their operational capabilities? This mystery adds an additional layer of wonder to the enduring legacy of these courageous space pioneers. The outer regions of the solar system present a noteworthy phenomenon. Consider the heliopause, a celestial boundary situated between the heliosphere and the interstellar medium, displaying dynamic behavior. Instead of remaining static, it exhibits ripples and unexpected angles, posing a mystery that perplexes scientists. The notion of the heliopause as a shapeshifter is not entirely novel. In the last decade, astute researchers, armed with data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite, have revealed the heliopause's inclination to change. These spacecraft, particularly Voyager 1 and Voyager 2, alongside NASA's Interstellar Boundary Explorer, play a crucial role by providing the sole direct in situ measurements of these cosmic boundaries, albeit at a specific point in space and time. Introducing Eric Zernstein, a space physicist from Princeton University, who shared insights via email with Vice. Zernstein highlighted IBEX's significant contribution to enhancing data analysis, facilitating the development of predictive models for the heliopause's dynamic behavior. Adding to the intrigue, recent research challenges established findings. IBEX, serving as a cosmic detective, recorded a distinct brightening of energetic neutral atoms in 2014, indicating unconventional asymmetries in the heliopause. Subsequent analysis revealed discrepancies with existing models, introducing an unexpected twist to the cosmic narrative. Additionally, researchers, leveraging data from Voyager 1 and Voyager 2, observed noteworthy movements in the heliopause within a surprisingly brief time frame. This discrepancy in the timing of the 2 probes entering interstellar space, occurring in 2012 and 2018 respectively, may be attributed to a mysterious behavior of the heliopause. This phenomenon not only bewilders researchers, but also contradicts established theories. In an article published on October 10 in the journal Nature Astronomy, scientists referred to these inconsistencies as entry speaking. In simpler terms, it poses a mystery that could generate cosmic discussions. However, the pursuit of answers is ongoing, with scientists planning to further explore the mysteries surrounding heliopause. They eagerly await insights from NASA's upcoming Interstellar Mapping and Acceleration Probe, a cutting-edge satellite scheduled for launch in 2025. This device holds the promise of unveiling more secrets from the distant reaches of our solar system. Until then, we can only speculate about the cosmic enigmas unfolding beyond the heliopause, the electronic aphasia anomaly. In mid-May 2023, Voyager 1 introduced a unique deviation from its regular operations. The Attitude Articulation and Control System, AACS, the onboard system overseeing the spacecraft's high-gain antenna, began transmitting perplexing data. Instead of the usual comprehensive spacecraft health and status reports, we found ourselves deciphering what appeared to be the interstellar equivalent of electronic aphasia, a condition hindering coherent communication. From our earthly perspective, it seemed as though Voyager One had experienced a bout of electronic confusion. The transmitted data appeared random or devoid of any discernible order, according to NASA's explanation at the time. Adding to the mystery was the fact that despite these unusual updates, Voyager One appeared to be in optimal condition. The radio signal from the spacecraft remained consistently strong, indicating that the antenna was accurately directed towards Earth, despite the AACS's contrary claim. Adding to the interest, Voyager 1's scientific instruments continued their data collection and transmission tasks without disruption, seemingly unaffected by the anomaly detected in the AACS. Additionally, the peculiar situation did not activate the spacecraft's fault protection system, designed to initiate a safe mode during glitches. Fortunately, NASA's proficient team swiftly addressed the issue, identifying that the AACS had been relying on an onboard computer that had been inactive for an extended period. The resolution involved a straightforward command instructing the AACS to switch to the operational computer for data transmission. The current challenge in this space narrative lies in determining the reason behind the AACS engaging in a celestial version of musical chairs. According to NASA, the system likely received an erroneous command from another onboard computer. Although NASA assures us that this doesn't pose a significant threat to Voyager 1's current status, efforts are underway to identify and rectify the root cause to prevent any future celestial anomalies. It's an astronomical enigma that keeps our space investigators vigilant. Over the past decade, Voyager 1 has been navigating the interstellar expanse, far beyond the protective influence of our sun's magnetic field. This magnetic shield, comparable to Earth's protective magnetic fields, functioned as a cosmic barrier, shielding the spacecraft from cosmic rays and other interstellar radiation. Think of it as the spacecraft's celestial armor, safeguarding it from the challenges of the cosmic frontier. Let us delve into the realm of technology. Similar to how energetic particles and solar radiation can pose challenges to Earth's computers, the onboard computers of Voyager 1 also face susceptibility to cosmic adversities. When swift energetic particles engage in a game of tag with a computer chip, it can lead to minor memory errors that accumulate gradually. Susan Dodd, serving as the project manager for both Voyager 1 and 2, provides a cosmic perspective on these phenomena. These space pioneers have embarked on an extraordinary journey spanning nearly 5 decades, surpassing their anticipated mission lifespan. Additionally, it is crucial to acknowledge their traversal through interstellar space, an unprecedented high-radiation environment that no spacecraft has explored before, sustaining Voyager's 1970s technology in space. For nearly 5 decades, Voyager 1 and Voyager 2 have undertaken a remarkable expedition, traversing vast distances, investigating uncharted realms, and achieving groundbreaking scientific breakthroughs. These renowned probes, presently engaged in their interstellar missions, confront a distinctive challenge. Their computer systems, originating from the 1970s, operate on a modest 70 kilobytes of memory, a remarkably small capacity by contemporary standards. Despite these technological limitations, NASA has effectively sustained the operational integrity of these remote sentinels. The complexity of this task is comparable to providing IT support on a cosmic scale, involving the transmission of software updates across immense interstellar distances. Consequently, in the profound emptiness of space, located billions of miles from Earth, the Voyagers have successfully transcended boundaries, granting humanity fresh insights into the enigmas of our solar system. Interstellar space reveals unexpected wonders, particularly through the remarkable achievements of the Voyager space probes. Currently navigating the vast expanse beyond our solar system, these twin probes, each comparable in size and weight to a subcompact car, symbolize the pinnacle of 1970s technological prowess in space exploration. Despite their computer technology being less advanced than today's digital watches and their analog TV cameras simpler than those used for I Love Lucy, the Voyagers have left an indelible mark on planetary exploration. The historical significance of the Voyager missions is evident in their groundbreaking discoveries on each planet they encountered. For instance, Jupiter, once perceived as a tranquil giant, was revealed to harbor numerous tumultuous hurricanes, a radiant aurora at its north pole, and intricately woven rings more complex than an elaborate braid. Saturn's rings initially thought to be countable on one hand, astonished scientists with the discovery of thousands of ringlets and seemingly braided structures previously deemed implausible. Voyager's revelations on a remote ice giant. The Voyager mission taught us a lot about the solar system when it explored Neptune and Triton. Triton, Neptune's icy moon, surprised us with its changing landscapes and unique qualities, challenging what we thought we knew about celestial bodies. The mission didn't just change how we see planets, rings, magnetic fields, and moons. It also paved the way for future explorations of outer planets. Neptune, different from Uranus, has a more regular tilt on its axis, leading to noticeable seasons. Even though Neptune is really far from the Sun, it takes an impressive 164.8 Earth years to complete one orbit. People experienced a full Neptunian year for the first time in 2011, long after we discovered Neptune. Neptune is called an ice giant, just like Uranus. It doesn't have a solid surface. Instead, it has a complex structure with different layers, pressures, and matter phases. Figuring out how fast Neptune spins is hard because it's so far away, but by studying its magnetic field shape, we can learn about its rotation. Neptune's atmosphere has different rotation rates at different latitudes. The equator completes one full rotation every 18 hours, while the magnetic field does it in 16 hours. Unlike Uranus, Neptune releases a lot of heat and energy into space, creating a lively weather system in its atmosphere. Neptune is a bit heavier than Uranus and has visible clouds and storms in its outer layers. The main gases in Neptune's atmosphere are hydrogen and helium, in a ratio of around 80 to 20%. There's also a small amount of methane in the upper atmosphere, giving Neptune a unique bluish color, similar to Uranus. Neptune's upper atmosphere is like a clear window to the sky, and when we look at it, we see some really interesting things. Scientists found that the clouds and patterns in Uranus look a lot like what we see in Neptune's visible sky. This similarity happens because there's more methane in the upper part of Neptune's atmosphere, and there's less icy haze covering it. The energy around Neptune makes its color deeper and darker blue, making it easier for us to see what's going on in the atmosphere. The Voyager 2 spacecraft carefully looked at Neptune's sky and found some interesting stuff. White clouds in the sky probably mean there are a bunch of tiny ice particles made of methane. One special thing they found is circular storms, and the biggest one is called the Great Dark Spot. It's kind of like the big storm on Jupiter, but this one is an anticyclone, meaning it's a high-pressure area, and it shows us what's underneath the hazy layers. The interesting thing is that, unlike the Jupiter storm that sticks around for a long time, the Great Dark Spot on Neptune didn't last very long. When scientists looked at Neptune again in 1994 using the Hubble telescope, the big storm had completely disappeared. Recent observations have discovered new storms in various places, suggesting a regular occurrence of storms appearing and disappearing. Scientists are still trying to figure out exactly how these round storms form and fade away. Neptune's atmosphere is known for having the fastest winds among all the planets in our solar system, even faster than Saturn's transonic belts. Around the equator, powerful westward jet streams move counter to Neptune's eastward rotation at incredible speeds, reaching almost 600 meters per second, or 1,300 miles per hour. This interesting behavior of the atmosphere makes Neptune stand out as a huge planet with special weather patterns, roaming the Kuiper Belt. Despite being much farther away from the Sun than Uranus, Neptune gets less sunlight, only about 40% of what Uranus gets. However, Neptune's own heat source makes it have the fastest and most lively winds among all the planets in our solar system. Not only that, but Neptune's gravitational force reaches far beyond its own space, and it has a big impact on the Kuiper Belt. This belt is like a distant asteroid neighborhood just past Neptune's orbit. If Neptune didn't have its gravitational pull, the Kuiper Belt might have combined into a faraway icy planet. In the Kuiper Belt, there are some small planets called dwarf planets. Some examples are Orcus, Haumea, and Pluto. Neptune showing up in their part of space probably played a big role in how these dwarf planets formed in the early days. It's interesting to know that Neptune didn't start off in its current faraway position. Instead, it moved to its current spot relatively late during the formation of the solar system. This adds another layer to the story of how our solar system came to be. Neptune's impact extends over large distances and plays a role in shaping what's happening in the outer parts of our celestial neighborhood. Beyond Neptune, there's a huge area called the Kuiper Belt. It's nearly 20 times bigger than the inner asteroid belt and is home to some of the oldest and most peculiar celestial objects in our solar system. This vast space contains mysterious things that scientists find hard to categorize, adding to the fascination with this distant region. Voyager 2 made a surprising discovery when it looked at Neptune. It found that Neptune's magnetic field is similar to its sibling planet, Uranus. This means that Neptune's magnetic field is tilted a lot compared to its rotation axis, just like Uranus. The strength of Neptune's magnetic field isn't the same all around its center. Interestingly, Neptune's magnetic field is off-center by about half the planet's radius, which is even more noticeable than the offset seen in Uranus. This challenges what scientists used to think, that Uranus's tilted magnetosphere was only because it spins on its side. The fact that Neptune shares this magnetic behavior with Uranus suggests that there's something inside both planets causing this unusual magnetic field. Voyager 2's exploration also involves looking at Neptune's interesting moon, Triton. Triton is a space object that makes scientists rethink how moons are usually formed. What's special about Triton is that it goes around Neptune in the opposite direction to how the planet spins. Plus, its orbit is tilted a lot compared to the planet's spin axis. This strange path makes scientists think that Triton didn't start out close to Neptune, but got caught by the planet's gravity. According to some math ideas, Triton is slowly moving closer to Neptune and will eventually get too close, breaking a boundary called Neptune's Roche limit. If that happens, Triton might break apart into a stunning ring system before possibly crashing into Neptune's atmosphere. Voyager 2 took a look at Triton's surface and found a mix of interesting features like round holes, bumpy ridges, big dents from impacts, flat plains, frosty layers, and a unique cantaloupe terrain. This kind of landscape isn't seen on any other space object. Scientists think that cryovolcanism, where landscapes are changed by erupting icy stuff like water, methane, or ammonia, is behind these cool features. Almost half of Triton's surface, as seen by Voyager 2, is covered in frozen nitrogen. This is kind of like what's on Pluto's surface, showing a connection between the two. Golden records in space. Triton and Pluto both have a frozen nitrogen layer on their surfaces, but Triton doesn't seem to have the dark reddish stuff that Pluto does. We're still figuring out Triton, and there's a whole side we haven't seen yet. Back in the 1960s, when telescopes looked at Triton, it seemed to reflect more red light than what Voyager 2 saw in 1989. This might be because of cryovolcanism, suggesting Triton looks different now compared to the photos from Voyager 2's visit 31 years ago. When Voyager 2 took pictures of Neptune with the sun behind it during its visit, it showed us new rings we hadn't seen before. These awesome pictures happened because the camera was exposed for a super long time, about 10 minutes, which is a lot longer than what we usually do on Earth. Talking about equipment, the twin Voyager spacecraft was equipped with various advanced instruments, including cameras, infrared and ultraviolet spectrometers, and sensors for mapping celestial phenomena such as charged particles and cosmic rays. Additionally, they featured a photopolarimeter and a magnetometer. Fueled by nuclear energy, the initial projection for their operational lifespan was 5 years. Astonishingly, the Voyagers exceeded this estimate, prolonging their mission by a factor of 10. Subsequently, the Voyager mission has achieved legendary status as it embarked on a daring exploration of the outer planets and ventured beyond. This endeavor transcends mere scientific pursuit. It has evolved into a symbolic rite of passage, acquiring a mythic quality. The captivating images of distant worlds captured by these spacecraft have engaged people globally, transforming the mission into a historic journey into uncharted territories. Noteworthy is the inclusion of the Golden Record, a remarkable feature. Each Voyager carried a phonograph record containing images, music, and sounds representing Earth, along with greetings in 55 languages. This compilation served as a cosmic message to potential intelligent extraterrestrial beings within the Milky Way, a hopeful and timeless communication across the vastness of space. Contemplating the prospect that alien civilizations might chance upon these recordings adds an element of excitement, offering the possibility of galactic recognition and perhaps a form of enduring significance. Now it's time for today's subscriber pick. NASA warns that Voyager One has made impossible discovery after 45 years in space. You see, for over 10 years, owing to the dedicated work of the twin spacecraft, humanity has been delving into the mystery of interstellar space. The probes have not only provided valuable insights into our solar system, but have also unveiled the peculiar and unforeseen aspects of interstellar space. Contrary to the serene depiction of a shining celestial body, our sun is an active nuclear furnace hurtling through the galaxy at an astonishing speed of 450,000 miles per hour. Picture this. The sun is surrounded by complex, interwoven magnetic fields as it revolves around the galactic center. emitting a continuous stream of electrically charged particles known as the solar wind. The sun's dynamics are far from static. Here's where it becomes captivating. The solar wind doesn't simply dissipate into the vast cosmic emptiness. It collides with the interstellar medium, a collection of remnants from ancient stellar explosions scattered in the spaces between stars. It's akin to the meeting of oil and water. They don't seamlessly blend. Instead, the solar wind forms a protective bubble within the interstellar medium, aptly named the heliosphere. Thanks to Voyager data, we now understand that this heliospheric bubble extends an astonishing 11 billion miles from the Sun at its leading edge. It encompasses the Sun, all 8 planets, and many of the outer objects orbiting our star. This heliosphere isn't merely ornamental. It functions as a shield, safeguarding everything within it, including our fragile DNA, from the majority of the galaxy's high-energy radiation. Envision it as a cosmic force field, assuring the safety of our solar neighborhood in the vast expanse of interstellar space. Cracking these cosmic mysteries demands a thorough comprehension of the heliosphere. That's why NASA has been providing cosmic IT support, ensuring the endurance of these distant sentinels by transmitting software updates across vast cosmic distances. It's somewhat akin to performing complex surgery on a patient located an astounding 15 billion miles away. Certainly not your typical Monday morning task. Let us know what you think in the comments. Beyond bug fixes, enhancing Voyager's software presents a significant challenge that demands a methodical approach. This complex process involves transmitting new code directly to the spacecraft's computers, which operate exclusively in machine language, the fundamental programming code. This means the code must be formulated in a language comprehensible to the hardware, devoid of the conveniences of an operating system or sophisticated programming tools. To overcome this complexity, NASA engineers employ a combination of ingenuity and resourcefulness. They utilize assembly language, a low-level programming language closely aligned with machine code, to meticulously compose the update instructions. This strategic choice affords them direct control over the hardware, ensuring optimal operational efficiency. Additionally, pseudocode, a simplified set of commands facilitating the automation of repetitive tasks without consuming excessive memory, is incorporated into the solution. It is essential to clarify that these software updates surpass mere bug fixes. They serve as vital support for our intrepid spacecraft. Over time, these updates have addressed a myriad of issues, ranging from revitalizing malfunctioning components to rectifying glitches in memory. Consider a pivotal instance where a software update acted as a lifesaver for Voyager One, averting potential disaster when a hardware component failed. This update triggered a fail-safe mechanism, providing the spacecraft with a renewed capability to continue its cosmic mission. Voyager's examination of Jupiter unveiled the complex nature of this celestial body. This revelation fueled NASA's enthusiasm, prompting the initiation of the Galileo mission in 1989, followed by the Juno mission in 2011. Voyager can be likened to the opening act for these prominent cosmic endeavors. But that's not all. Voyager's celestial exploits served as the inspiration for the renowned Cassini mission to Saturn. According to Jonathan Lunine, a distinguished planetary scientist at Cornell University, Voyager One's close encounter with Titan, Saturn's moon, acted as the catalyst for the spectacular Cassini mission. In 2005, Cassini even deployed the Huygens probe onto Titan's surface, capturing and transmitting remarkable video footage. Voyager 2 was not idly observing from the sidelines either. It initiated investigations into the ice giant planets, not only within our solar system but also in distant star systems. Consider this: a significant portion of the exoplanets discovered to date share a resemblance in size to Neptune and Uranus, with Voyager 2 contributing significantly to this cosmic detective work. Fast forward to the present day, and NASA is still leveraging the legacy of Voyager. The Dragonfly mission is poised to reach Titan, Saturn's largest moon, in 2034. Simultaneously, the Europa Clipper is gearing up to study Jupiter's ocean moon, initially identified by Voyager, commencing in 2030. Remarkably, the National Academy's Planetary Science Survey has recommended a $4.2 billion Uranus orbiter and probe mission in the 2040s. This proposes a space rendezvous with the enigmatic ice giant planet and its moons. What's truly fascinating is that all these future missions trace their origins back to Voyager 2's brief visit to the Uranus system in January 1986. Now, both Voyager 1 and Voyager 2 continue to maintain communication through NASA's Deep Space Network. Originally designed to communicate with Voyager 2 during its missions to Uranus and Neptune, this network still receives regular commands and occasionally transmits data back to Earth. Estimatio Crimus, the principal investigator for the Voyager 1 and 2 probes and the Voyager interstellar mission, shared updates during a press conference at Chios Par 22 in July. According to Crimus, we are actively collecting data from Voyager, and the intention is to sustain the interstellar mission for another 5 or 6 years. By the mid to late 2020s, the scientific instruments on these space probes will be deactivated, rendering the spacecraft inert. Nevertheless, their perpetual journey into the cosmic unknown will persist indefinitely. Crimus, now in his 80s, humorously remarked, "My goal is to outlive Voyager, but I'm uncertain if that will transpire." Interestingly, approximately 300 years from now, both Voyager 1 and 2 will traverse the Oort cloud, a region filled with comets encircling our solar system. Subsequently, about 30,000 years later, they will bid farewell to the solar system and silently orbit the center of the Milky Way for millions of years. While their scientific activities may be winding down, Voyager 1 and 2 are just embarking on the commencement of their extraordinary journey through the cosmos. Thank you for watching. See you in the next update.